Let's traverse through this array and try to understand insertion sort. So the name of this array is ARR, and these are the numbers, right? We'll try to sort this array using insertion sort. All right, so insertion sort is a very simple idea. We'll start with the second element, which has the index 1, and then we'll move through this array one by one. And the point where we encounter an element which is lesser than its previous element, we'll store it in a temporary variable, and this place will be vacated, and the rest of the elements will shift to right hand side by one index. And when rest of the elements shift on the right by one index, the element which was stored here will be sent to the vacant place, which is created after all the elements have shifted to their right place, right? So let's perform this whole operation for each element. We'll see if the array gets sorted in the end or not. So we'll start with the second element, which has an index 1. So I'll note it down here, ARR of 1, and index is 1, right? So it's 51. ARR of 1 is 51. So what we're going to do is we're going to store 51 in a variable temporary, and we'll store temporary index 1 as temporary index, right? This 1 will be stored in temporary index. Then we'll compare temporary with the previous variable. That is temporary less than array of temporary index minus 1. What is temporary index? That's 1. 1 minus 1. That's array of 0. Okay, that is 43. Is 51 less than 43? It's not, right? They are in proper order. So we move on. So we move on to the next element, right? Okay, but why did I use temporary index here? Why not? Why I can't use just I? Array of I minus 1, right? That will also do, right? It's a very important question which I'll answer as we move forward. Why temporary index? Why not I minus 1? I am noting this down here, right? Which I'll answer as we move forward, right? So 51 is less than 43. So they are in proper order. So we move on. Next is array of 2. That is equal to 67, right? So I is now incremented to 2. The value of I is 2 here, and we store 67 again in a temporary variable. And I store 2 in a temporary index, right? And then I compare if temporary is less than array of temporary index minus 1. All right. So temporary is 67 and array of temporary index minus 1. What is temporary index here? 2. So 2 minus 1 is array of 1. That is the previous element. So previous element is 51. So is is 67 lesser than 51? No, it's not. So again we move on. They are in proper order, so we move on. Next is 32. Okay, 32 I'll store in temporary. So we are at third element. No, it's actually fourth, right? By index it is the third element. So array of 3 is 32, and we are at the third value of I, right? And temporary index is 3 here, right? So is temp less than array of temporary index. What is temp? 32. What is array of temporary index? -1. Temporary index is 3. 3 minus 1. That is the previous element. The previous element is 67. Is 32 less than 67? Yes, it is. Right? Now it will start a new course of action. Okay. So what we'll do? We'll leave temporary as it is, but 32 will be kicked out from this place and all the elements will shift by one index towards right. I repeat, temporary will be left as it is. 32 will be kicked out from the third index and all the elements will shift to right. That means A of test index is equal to A of test index minus 1, right? And test index will keep decrementing with each iteration, right? So I want you to read this again. Test index, A of test index, that means A of 3, the value of test index right now is 3, right? Will be equal to A of 2. That means this 32 will be kicked out from its place and 67 will replace it, right? A2 of value will be transferred to A3, right? A of test index is equals to test index minus 1, and right after that test index is equals to test index minus 1. That is, the new value of test index will be 2, right? And it will again move here, which means A of 2 is equals to A of 1, right? So A of 2 is equals to A of 1 means 67 will be replaced by 51, right? And then again it will move to, then again test index will be decremented. So again 2 minus 1 and the new value of test index will be, 1. So A of 1 is equals to A of 0. Okay, so which means 51 will be replaced by 43. Okay, and once it reaches 0, right? Once test index reaches 0, I put the value of temporary to A0, right? Here A0, here A0 will store 32, which was kicked out of its place. So that's the right place of 32, 0, 1, 2, 3. And this entire batch of statements will be inside a loop. While test index is greater than 0 and we merge this condition here. So temporary should be lesser than array of temp index minus 1. Okay. Also because while swapping this temporary value, it should be lesser than all the previous ones, right? Then only it will reach its right place, right? So it keeps a check on that also. And test index has to be greater than 0 because this entire thing starts from the first index. And once this loop is over and once it's done, after that, once all the swapping to the right hand side is over, we store temp at its right place. That is the current value of test index after all the swapping to the right hand side. So this is swapping. So this is the swapping loop. So after this loop, the current status of array is 0 is 32, 43, 51, 67, and at fourth place it's 69. At fourth place it's 69, 73, and 25. So the master loop will increment now. That's ARR4, which is equal to 69, and I is equals to 4. So again, the temp will be 69. Temp index will be 4, and we'll compare if temp is lesser than array of temp index -1. That is the previous element, right? Okay, now, so by the way, I hope you realize why this is temp index, why I have used temp index here and not I. The role of I here is just to move through the elements one by one. The role of I here is just to move through the elements one by one. And once we encounter an element, temp index takes over, which is used for doing all the swapping and putting the elements in its right place. Okay, so if I use I here, then the main loop, then we won't be able to traverse through the rest of the elements. So we are actually using two loops here, right? One is to traverse through rest of the one is to move through the elements one by one, and then when we find a misplaced element, we use temporary index to put that element in its right place. Okay, so is temporary lesser than array of temporary index -1? So 4 minus 1, array of 3. What is temporary? 69. And array of 3 is so now array of 3 is 67. It's not 32. It's not 32 anymore, right? It's 67. So is 69 less than 67? No, it's not. So we move on, right? We move on to the next value. That is array of 5, 73. 73. I is equals to 5. So temporary value will be 73, and I and temporary index will be 5, right? Is temporary less than temporary index? 73 minus 5 minus 1, that is array of 4, all right? Array of 4 is 69. So is 73 less than 69? No. So it won't go inside the loop. So it will move on to the last one, that is array of 6, that is 25 at I is equals to 6. So temporary is 25, temporary index is 6, and is temporary less than array of temporary index -1? So temporary is 25 and array of temporary index -1 is array of 5, right? Array of 5 is 73. So 25 is less than 73. So now it will enter inside this loop here. Inside this loop, it will do all the swapping. That means 25 will be stored as temporary, right? And temporary index will be 6, and it will keep, and temporary index will keep decrementing till all the elements move to the right. And then once all the elements move to the right, 25 will be stored 25 will be stored at its right place. So we'll get our final array, that it's 25, 32, 43, 51, 67. If you want to implement this in C++, that's how it looks like. Here we declare an insertion sort program with a return type void, because we are not returning any value, and we pass an integer with its size. That means the number of elements in the integer, and we declare I to run a loop temporary with temporary index, and we run from I to n. So this is the master loop which traverses through all the elements one by one, and at each iteration we store the value in temporary and temporary index, and then we check whether the temporary value is smaller than its previous value. If it's smaller than its previous value, then we move all the elements to the right. With each iteration, the value of temporary index it decreases. Temporary index decreases by 1, and once the loop is over, this defines the loop end till the temporary index is till the value of temporary index is greater than 0. This loop will run so that all the elements move to right hand side, and then we and once it's over, then the value which was stored in temporary here, right, that means the value which is actually misplaced, it gets stored in the current temporary index. It gets restored in its right place, right? And then we print the array. And in Python it works like this, and we pass the array with its size, and it runs the loop and from 1 to n, right? And we store each element in temporary. We store each element in temporary, and the index in temporary index, and we run that same loop. If we found an element smaller than the previous elements, we move all the elements to the right hand side. We move all the elements till temp index is greater than 0, and then after the movement is done, we restore the temporary value to its right place, and then we print the array. So after we execute this function, if you input this array, then you will get this answer. So hope I was able to explain the concept well. If you have any doubts or suggestions, you can write in the comment section. And if you find any error in this video, let me know, because I am also learning, so that will help me as well. And subscribe to this channel for more videos on data structures and algorithms.